Hi, this presentation will show you how to prove some identities. It mainly covers C3, Core 3 area of pure mathematics for A levels. What you need to know in for these identities, I mean, we will go through at least 3 examples today. You need to know double angle formulas. I mean, what I can see is, I can see that I've got few double angle. I've got double angle here, cos of 2a. Okay, what we need to do is we need to prove that side equal to that. So what I do is I will just write down here the double angle formula for cos. Okay, I know that cos of 2a is equal to cos squared a minus sine squared a. Now that is something which I'm going to use in this one, right? So I've got more of stuff on left hand side, so I must make a start from left hand side, right? So I'm going to start here from left hand side. Okay, and on left hand side I've got cos of 2a over cos of a plus sine of a. Now if I write the formula down here, it's cos squared a minus sine squared a, okay, which is divided by cos of a plus sine of a. Now cos double angle formula, if you think about it, it's actually a difference of two squares, right? So if I write it down, if I try to factorize it, I will get cos of a plus sine of a multiplied by cos of a minus sine of a. Okay, now if I divide it by the term cos of a plus sine of a, now I can see that that factor cancels out with this factor. So if I cancel them out, I'm left with cos of a minus sine of a. If I check carefully, that's my right hand side, so that's proved. Okay, if I go further on, I've got another question here. Now this question involves, if you want to have a go, I mean, you can pause the video and you can try it first. This question involves two double angle formulas. I mean, we talked about cos 2 theta before, which is difference of cos squared and sine squared, right? And we also need to know sine double angle formula, which is 2 sine of theta cos of theta, right? Now if I start from left hand side again, because left hand side seems to have more stuff on this side, so we need to make a start from this side. If I write down 1 minus, and if I put down the double angle formula for that, which is cos squared theta minus sine squared theta over sine. Now if I change that into single angle formulas, double angle as well, so it's 2 sine theta cos of theta. What I need to prove that side equal to tan. We know that tan is sine over cos, so somehow we need sine at the top. Okay, so if I change, for example, if I change cos squared into sine, I must get 1 minus sine squared theta, because cos squared theta and sine squared theta is equal to 1, and rearranging that gives you that. Okay, minus sine squared theta. Now that's still divided by 2 sine theta cos theta, right? If I put that, if I try to make it equal, I mean, I need to expand that bracket now, so I've got negative sign outside, which will change everything inside, all signs inside. So plus sine squared theta plus sine squared theta, okay, divided by 2 sine of theta cos of theta. Now these two cancel out, so if I get 2 sine squared theta here, I've got 2 sine theta cos of theta in denominator. Now if I check this, that's a square function. I will first cancel 2 out with 2. That squared function cancels out with one of the signs, so I'm left with sine of theta over cos of theta, and at this level you should know that that's equal to tan theta. So that is your right hand side. Okay, so in this identity we used both double angle formulas. If I go on to my third question for this video, I've got sine of b over sine of a, which is equivalent minus cos of b over cos of a, and we need to prove it equal to 2 cosec 2a sine b minus a. Now I've got different denominators here, so to make denominators equal I need to multiply first fraction by cos of a, which will make it sine. If I multiply that, I get cos of a sine of b, and if I multiply that to both of them, I will get cos of b sine of a. Okay, and obviously I can write them down as a single denominator. So I've just started from left hand side. Now I can see that that is actually an addition formula. Okay, cos a sine b minus cos b sine a. So that actually is a formula for cos of b minus a. Okay, now I can change sine a cos a into a double angle formula if I times this by 2. Now if I times that by 2, I need to times the numerator by 2 as well, so it's 2 cos b minus a. Now that changes if I write it down, 2 cos of b minus a at the top. Now that should be changed to sine of 2a, because sine of 2a is equal to sine a cos a, right? Now that's a double angle formula. Now sine of 2a, if I look at my identity, what I need to prove 2 cosec 2a sine b minus a. Okay, in fact I think I need to cos a sine b minus cos b sine a. Now I need to, now that actually is a formula for sine addition formula. So this is 2 sine b minus a. I rushed through it. Now if I look at this one, and if I look at what I need to prove, cosec 2a, now if I take reciprocal of that, that will make cosec 2a, and reciprocal of that is obviously going to go up in numerator. Okay, so sine 2a can go up to change it into cosec 2a. Okay, and second part is b minus a. Right, that's what we need to prove on this one, right hand side of my. So there was a bit of confusion here. Okay, now so cos a sine b minus cos b sine a is actually sine b minus a, not cos, because cos b minus a is cos a cos b and minus sine a sine b. In fact that should be plus though, plus sine a sine b. Right, okay, thanks for watching.